Cody, I can hear you.
Yeah. We're here. We're
That's
good.
the sweet.
We're here. And the
Okay.
stream ended now.
Yeah.
That's how we start. Okay, so we are live, and we are live on Facebook too.
Could be. I'm checking.
Should we give us just a few seconds to see everything? And Cody, I can see the behind the YouTube thing.
Yeah, I
Don't show
switched.
people
I
the-
switched. It's good.
Okay. You show them the stream key and then they.
Absolutely. Everybody has it now. Just take it over.
Okay. So as soon as we confirm.
There we go. Facebook should be going now. Okay, we're good.
Perfect. Okay. Trom-Cast. And before we start the Trom-Cast, let me give you a few updates. So, if you know or not, we have this custom Linux distribution called Trom, and we try to keep it open and like it's not only open source, but it's trade-free, meaning that it doesn't promote trade-based applications, like those applications that ask you for ads, not for ads, for data, or put ads in your face and so forth, or ask you for money. And you can find it at Trom.com. Recently, Dave helped a lot with Trom, and he was the mastermind behind making it work. But Dave cannot help anymore, so now I have to do everything, and we have to kind of reboot it a bit. But I'm happy that I managed to understand how he did whatever he did. But I want to say that a huge thanks to the guy, because he helped a ton for the past half a year or so.
Dave is
yes, thank you, Dave.
Come back, Dave.
Yeah, fucking fantastic job. Because I used to do it in a really shitty way, not in this kind of professional way, with all repositories and all packages and the way that he did it. So now he laid down. He not only that he helps, but because this is open source and everything is hosted on GitLab, it's a website where people post open source projects. You can see exactly the steps there that he did and all of his work, and anyone can contribute. So because it's open source, anyone can help with this. So I want to tell people, if anyone wants to help, that'll be fantastic. Just email us and from comsci.com/contact, and I'll be super happy to have more people helping with Trom. So that's what I want to say. If anyone wants to help, that would be fantastic, because I was a bit surprised when Dave left. I always used to say oh my god, if Dave leaves, I'm fucked. And I told Dave times, be careful if a bus hits you, man. I cannot do it anymore. But apparently you can learn anything. So I learned a lot in these past days stuff. And that's it. Go and create Trom if you can. And speaking of that, of open source, we are going to have a different kind of podcast maybe today. We try to, maybe I was thinking to invite people from different kinds of projects that are similar to ours, or they talk about volunteering or open source, hardware and software and so forth, automation. I think it would be a cool idea for them on Trom-Cast, and we can discuss with them about their projects and related to their projects. So today we are going to talk with James. James has this really cool project called Stone, if I pronounce it well. It's a really interesting open source hardware project, and I will let him explain a bit more, and then we can go on from there. So James, if I didn't know what do you do at all? How can you explain to someone who doesn't even know much about open source hardware or software and so forth? What do you do, and what's your project?
So the project is to build a set of small modular machines. They're small to be inexpensive to start with, and they can grow to be large. But they're small to be inexpensive. The first batch of machines, the idea is that it will work as a mini factory. So there are 8 machines. They're about 600 millimeters on a side. So they're actually very small, or for Americans, 2 feet.
Mm-hmm.
The small machines all work together, a coordinating piece of software, and the idea is basically to turn stuff into digital templates, to get away from physical distribution of goods. Because right now, there are newer that there are articles on the ocean. 3,000 of them are some sort or other moving oil, natural gas, carpenters, whatever. So there's 50,000 ships on the sea at any time. Actually, is that the most likely way for a baleen whale to die never by a ship. They're actually into whales. So there's just too many ships on the sea and there's far too much shipping. And it's because our distribution model might have made sense in the 40s to start centralizing manufacturing and shipping stuff around. But it doesn't make sense now because it's too much shipping. Billion tons of materials are moved constantly. So the idea is build small local machines. So this set of machines that I'm building are machines that are affordable, that you could set up in a hackerspace or for a community. And then the initial machines will do manufacturing. And the idea is because they're modular, we can add additional machines to the system over time and continue to expand it towards very effective at recycling at the local level. Because distribution right now, consumer goods, what a big metropolitan center can get to, and what centers have. They have a waste problem. Well, that's waste is that people don't. So all the materials are already in the communities where they need. It's already there. And if you put localized small-scale factories in all of those locations, turn all of the goods into digital templates, then people can make stuff that they need wherever they are out of the stuff that's already there. You eliminate most of the shipping. You eliminate a lot of the materials cost because recycled materials can be made to be very inexpensive, especially they're on the 4th or 5th trip through the system. You know, every time they go through, the value or the price of the materials goes down a notch because you've removed the shipping component, you've removed the original refining component. All of those things tend to go away. So you have this material spiral towards zero. And if you generate energy locally, kind of as a side effect, you end up with a distributed resilient grid. And so the idea behind the system started out as just a manufactory, but it's the convergence between material shipping, labor issuing, as if you have distributed system inside of the community, you eliminate the mechanism for the concept. So it inherently removes inequality.
James, sorry to interrupt you. Is like your chat, like sometimes we cannot hear you. Maybe your connection is not that great. So you can either maybe turn off your your video stream when you talk, or maybe something it's making your internet busy.
I'll minimize that. Did that help?
If
You'll
I
have
think to talk a little bit.
yeah.
if you kill the video stream, it'll give you enough. The bandwidth will transfer over to your audio so that we can hear you clearly. Just when you talk, and then you can flip it back on.
Alrighty. So I'll mute out my camera.
Should be good. Okay. Yeah.
All right. We'll give that a whirl.
Yeah, we'll try this.
That's right.
We'll try anything once. That's the way we do it.
Anything.
I think your audio is much better now. Yeah.
Yep. It's a lot less choppy right now.
Okay.
Okay. Well, where should I go from here?
Yeah, I was thinking that we basically talk here about manufacturing, and as far as I understood from your project, what you want to focus on is, first of all, you are talking about the fact that when we manufacture in today's world, it's extremely inefficient because we manufacture in one part of the world and then transport to another part of the world, and that consumes a lot of energy and resources, even to transport all of these goods. And what you want to do is to switch that to a more local manufacturing, because you say we have enough materials to manufacture locally. Is that correct?
That's correct.
Yes.
Yeah,
and
it is.
what is your your plan here to how that could look like, manufacturing locally, basically?
Well, hackerspaces are one potential location to start manufacturing. Another one is for intentional communities to base intentional communities over material self-sufficiency. So they could you could set up a small community. This is sort of what I'm doing in Texas. Mm-hmm. And the idea is to set up the community so that it starts out initially focusing on food production and some of the other sort of basic things that you would expect for any small self-sufficient community. But manufacturing component means that you can create templates for all of the systems that you use to grow your own food and distribute those templates as digital templates. So basically you have a downloadable village, self-sufficient village, where all of the resources within that village can be committed to templates. And the idea is that that's a big job, it's a complicated task. So no one person is going to do it. So if you do it as an open community and then capture all of the innovation in that open community, that somebody in Botswana comes up with a better water capture mechanism, it's particularly applicable in Texas, and vice versa. So you're taking the power of the worldwide crowd to solve problems, and then you're reapplying those solutions where they're most appropriate. And by committing them to a template, you can easily duplicate all of the technical parts that are necessary to get it to work and potentially refine it.
And one big thing that, just to talk a bit about a really good point that you make here, one big thing that people may not realize today is that this digitization of physical goods, it's a huge advantage in not only distributing the goods around the world, but distributing the manufacturing of them. Because if you digitize, in the past, if you build, let's say you build a house or a hospital or something, you have local knowledge basically. But today you can digitize that, and people not only have the access to the knowledge how to build it, but they have access to directly exactly the files, the 3D files and whatever files they need, the technical blueprints to build that hospital or that house. It's like open source, going from just digital, going into the real world. Is the connection, I would say, between the digital, and the real world. And I think that's a huge, it's a massive thing. And I think that's one of the things that you rely upon, right, with your project.
Right. Well, and the idea is basically to digitize not just the object, but the quality control and all of the other things that relate to it. So you're actually digitizing the knowledge necessary to recreate that in another place. It's far beyond just, like, you can go to one of the 3D printing libraries and download an object and print it, but without context and without the necessary background knowledge, what is that object and what does it do and how do you apply it and what purpose does it serve? So digital templates for goods, to me, means a template that not only gives you access to the good, but also the context to apply it within. So I think that changing over to a digital distribution model is a lot larger than just the objects themselves in terms of its potential impact. And then also moving towards a international open source community for solutions. I think that one of the good examples is the 3D printed prosthesis for kids with no hands, kids that have lost their hands or were born without them or whatever. The 3D printed prosthesis, that allows people to access to medical technology at very low cost, and also, something that's very dramatically life-changing for somebody who's lacking a hand. So you're getting a whole nexus of benefits. It's not just one thing; it's a whole bunch of things that sort of alters the structure of society.
Mm-hmm. Absolutely, yeah, absolutely. And I was thinking that it's also it empowers maybe collaboration. It really empowers it because, like you explained, and this thing is so important in the also the software open source world. You make a piece of software for a certain purpose because it's open. it's very likely that someone else can take that piece of your work, that piece of software, and repurpose it. It's much easier to repurpose that than to reinvent again. And that's also what you're talking about, because like you're saying, you're making a machine that will do a particular job in, I don't know, some parts of Africa, or the other way around, and people can take it from, take the template and build it in another part of the world, and even build upon whatever you made and post it again, make it open source, open it like exactly like you did, and then others can build upon that. And it's like this continuous growth, of collaboration, and of you expand you just create like Linux, you create the kernel, the core of Linux, and then people build upon that, and they make many distributions and many applications because of that.
Well, and Linux itself, the premise of Linux, small, modular, component. I can't remember exactly who the quotation comes from, but it's so the Linux philosophy: build small applications that accept input, produce output, and perform one thing well. And that's kind of the idea behind these modular machines as well. As you take one industrial process and capture it to a machine. Machines then plug in a lot like an old tube radio. Each the system is a set of rectangular receptacles that accept the machine, provide it with electricity, provide it with digital connection, and then whatever goes inside of there. I mean, the machine could make bread, it could print tissue, it could cut metal. It doesn't matter what the machine does, because each machine is a self-contained module that performs some industrial step, one step in a process. So then you can combine them like Lego into an industrial process. And the example I think I used in the TED Talk was, if I create a machine that sorts turnips, you have a vision system that's going to look for blemishes on the turnips, and you have a manipulation system that's going to pick and place and throw them into the right bin or whatever. And somebody comes along and says, well, I don't like turnips and I don't grow turnips, but I need to sort tennis balls because, we're recovering tennis balls from a tennis court or whatever, some commercial application. They could apply the same system and make very small modifications to it, and it would still work for that. And a third person might come, or a third party might come along and look at that and say, well, that's all ridiculous. I don't need to do any of those things, but I do need to grade eggs. And so you would add some capabilities to it, and it could examine the eggs and make sure that they were the right size and weren't cracked and didn't have an embryo in them, all of the things that you do when you grade an egg. So, and it's essentially the same system, and they're completely different functions, but it's basically the same system, which means you can borrow a lot from the original design and apply it to a new purpose. And that's exactly what you were just saying, that repurposing, that's why I think that by having an international group of people who are working on solutions, all the basic problems can be baked in to in a fairly short time. They'll develop to a point to where they're applicable, whether you're in sub-Saharan Africa or you're somewhere in Asia. The same kinds of general solutions people need: air, water, food, and shelter. They have the same general set of needs. And so those problems, all the basic problems, can be covered in a relatively short time. And with local manufacturing, it also can't be suppressed. You can't create artificial scarcity and limit people's access to it.
Right.
So this opens the door, in my opinion, if you were to distribute this everywhere. And people have brought up security concerns. You could apply it for bad things. Well, yes, you could. But that's most people are more, you can do that with anything. But most people will apply it to improving the quality of their own lives. So the overall good far outweighs the potential bad. And if you give everybody in the world access to all of their basic needs, they have a lot less motivation to do bad stuff, because they're no longer being repressed or feel that they're in competition with somebody that they have to harm to save themselves. All the crap that motivates aggression in the world.
Right.
So I think this is a fairly significant development. I also don't necessarily take credit for it's evolved, because the first thing I wanted to do was just build machines that would do some of the work for me. The idea of access to automation, I think that's an issue that people haven't really grasped yet either. Automation is taking away your job, right? Well, no, it isn't. It's doing your job, it's doing your job in a way that frees you up not to have to do that job. So automation is a great tool for the liberation of mankind. It's not, but it's being misused by commercial entities to put you under pressure, commercial pressure. You know, all they're doing with their workers now is filling in gaps in their automation in most factories. That's what a worker is today. That's why work is so unstable, because you're just filling in the gaps between pieces of automation that exist. So if you make automation universally accessible, well, that's going to end, because if you have a small machine in your community that produces most of your basic goods, or a small set of machines, then you have access to automation. You and as an individual can access the enormous potential that it's taken hundreds of thousands of people a century to put together, getting the inanimate to do work for you. It's a pretty amazing achievement. It's actually magic.
Yep.
So some people may argue that okay, you open source that, but who is going to basically use it? Because they will say the same with software. Okay, Linux, it's open source, and other operating systems and applications and packages that build upon Linux are open source, but very few people, they will say, very few people know how to use those and how to implement. And we are talking about software. What about in terms of hardware? Even if it's open source, now who is going to have the power to build these things and maintain them and build upon them? And
I think that is contingent upon the technically knowledgeable to enable it so that it can reach the non-technical. I want grandma to be able to order something from this system and get it. But she may not necessarily, ever be interested in understanding how it was made. And that's okay. But the idea is basically that at the lowest user level, it's a store that you can get free stuff from. And at successively higher levels of engagement and interest, it becomes, enormously technical. It's a very complex system, but it doesn't have to be complex to use. Essentially, it's a web page you order stuff off. In other words, it's Amazon. It's Amazon, but it's open source Amazon that uses locally recycled materials and energy that it captures from either the sun or a river or whatever. So that's really the goal. The goal for me is to get through the first stage, get the prototype built, get it functional, build a couple of commercial verticals so that you can fund further development, and keep the core of it as open source so that anybody can apply it. It won't take very long until we're in a money-free world. Because if you can produce goods without cost, then you have wealth without money. That leads us to a place we'd like to go. Hopefully.
I like that.
I think one key takeaway about this idea that people need to understand is that it doesn't function like an aggregator. It doesn't, it doesn't force people to centralize things and bring things to one place for shit to get made. And that's the opposite of what we've been doing with the Industrial Revolution. Everything has been about bringing shit from one place to another and then moving shit from. So this is where the system can spread out, and depending on what the needs of each place is, the system can adapt. And the moment you start cutting down transportation costs, it's not only better from a fiscal perspective, but also from an environmental perspective, because you have to burn lesser fossil fuels. You can easily rely more on green technology and renewable sources. It's super, super exciting. We haven't, I think pre-industrial era, we had something like that where, every city, every town had 3 or 4 tailors. Every street would have a tailor or a blacksmith, and entire towns and communities built around these small shops, which then turned into markets. Markets themselves are places where things get accumulated, right? But this is the anti-market. This is the anti-market. You still need goods to be produced. And while it is far easier to provide services on a trade-free basis, I think this is the first real step that we can see where we can start producing goods trade free. It's very, very, very important.
And
well, it's a return to the model that we had before we consolidated everything. So centralization is actually a recent occurrence in history, because there was trade, but what did people trade? Well, they traded spices and silks and things that were very expensive, but also very lightweight and small relative to the. They didn't move copper ore by the shipload from one part of the planet to another to be refined, because it was a ridiculous concept. They moved small, light things. And I think that there could be a return to that. I have much crazier ideas and a much bigger idea in like rewilding, North America by redoing the cities in places where we've always built in river bottoms. Well, we built there because that was where all the action was. There was good soil, there was lots of game, so we concentrated in river bottoms. What we should do is rewild the river bottoms and move to the desolate highlands, because the desolate highlands we can easily turn into a very comfortable environment now. We couldn't then when we founded all this infrastructure. Right. So, and the other thing that people don't seem to understand is they say, well, it would be expensive. Well, not in a money-free world. It's an energy problem. It's a physics problem. It isn't a money problem. Money is this external factor that, if in any field of human endeavor you took the entire problem and converted it to a arbitrary external variable, manipulated variable, and then tried to move that back into the problem as a solution, you'd be laughed out of the room. But finance is exactly that. It's the wrong solution for everything.
Wow, it's good.
But these things that we are talking about manufacturing stuff, but people may think, okay, what kind of stuff? How much? What's the range here? Can you really expand it and make it like as big as building parts of, I don't know, large structures, from bridges to buildings, from food to, how much of flexibility is in this of potential is in this kind of systems that you're talking about?
Well, I would say look at the systems as they exist today. Things are built to the necessary scale, but they're not integrated into a unit standard. So the only thing that this does that's different is we start off with 600 millimeter cubes, and inside those cubes we build it's a 3D printer, desktop. So that's a starting point. Types of, and I'm sure there will be more, but I'm not necessarily smart enough to think all this stuff up. First part. So first 4 machines fell and handed into the machine. Something pulled out and then moved to another step. Another pass through, trained in one axis, so they can make it very long, so high and so wide. So those parts, that's the way that these machines can make 80% of their own parts, because the structural pieces that are around the outside of the machine are 554 millimeters long, 600 millimeters. So because of size, the machine millimeter work envelope. So there's no that 500 millimeter part in a 200 millimeter, and you just pass it through. Work on one end, move it forward a ways, do some work on the other end, and part that is work envelope. So the pattern can build truss-like structures, which means that I have for a geodesic dome building that's 30 feet can pass through a machine that's only 2 feet in size, because all of the structural members in it are that are joined together. So because of that, very little machine, big parts, but more importantly, the machine down by doubling. Scaling upside, so I can make the frame part 600 millimeter machine, but I can make the frame parts for 0.4. You might think, why didn't you just go with stuff? The meter is the wrong size. If you want to make if you want to print a XXX t-shirt, it won't fit in 1 meter. It has to be 1.2. And the other factor that influenced me was 300 millimeters is roughly a foot. I live in the last country on earth that uses imperial measure. So now we have officially converted to metric in the United States. I don't see any evidence that it's happened. Everything is still feet and inches, acres and pounds. It's all around me. No kilograms. I mean, in packaging that they have the conversion, they have some weird unit size in liters, but it's stupid. We're stuck in fast because we're the empire.
No, I mean it would have made more sense if everyone used the dozenal system, not the decimal system. And because the imperial unit is made for the dozenal system, we don't count in 12s. We count in 10s because we've got 10 digits in our hands. It's right. But from a geometrical point of view, we don't build things in. At least I'm an architect, and I know that sometimes when I use the base.
Chas, you died.
I believe you dropped out. Note to self: don't talk about basic units.
That's right. Yeah. Oh man, they're coming for you. The empire.
So, but what he was saying, the other motivation for me in an imperial system is that 300 millimeters is about a foot, which means I can buy material in feet and inches and turn it into 600 millimeter stuff with absolutely no conversion and no waste in terms of, I don't have to cut stuff down or make stuff longer to fit my unit system. I can make stuff in feet and inches. I do make things in millimeters, but it's so close. It's 11 inches and it's only like 300,000 short. It's a very small difference between a foot and a 300 millimeter stick. So that way I can live in this supply chain, make stuff that is international, and everybody stays moderately happy.
So what are some examples of the kind of products you would make at least with the first cube? Or so the first
the first set of machines is a small metal cutting milling machine lathe, 3D printer, and a roll.
Cutting out a little bit.
In millimeters.
Yeah. You're cutting out in millimeters here because we can only hear every
other word.
Every other word sometimes, so it could be. Yeah, I don't know. Your internet might be not.
Well, that's unfortunate, but
yeah. Okay, well, I don't know if we can do anything, but we'll tell you whenever it happens. Maybe you can start a bit more slowly. Maybe the bandwidth won't like.
I'll say everything twice, but I'll say it offset by one word.
That's good.
You figured out a system.
Okay, I think it's fine.
We will defeat the technological problem.
Let's hope.
Anyway, I think this is something where you can see what the potential is, and I don't claim this. I've started it, but it's the world, so it's your project too. And the thing about it is, I need about $300,000 to finish the set of prototypes. The prototypes are very expensive because I have to use all conventional means of getting them produced. I have made a partnership with a recycling center that recycles machinery, and I get all of the materials and stuff from them. But living expenses and stuff aren't covered by that arrangement, so I still have to, and it's not convenient. It's about 2.5 hour drive away to the machine shop. So it doesn't make sense, 5 hours a day to drive there and drive back. So I have to camp out when I'm there. And that means that there are external expenses. I've spent about 5 years building this. And during that 5 years, I have 2 supporters. And those supporters have probably spent about $30,000 a year to keep me alive and keep things moving forward. So all told, between that and the wages I haven't taken, and the cost of materials and all that stuff. We put about $90,000 into hardware development. I estimate that it's cost about $900,000 in opportunity cost, because I could be making $90K a year for the man.
Right.
And so all that money is gone, or not coming in rather.
Right.
And so the idea of crowdsourcing the support for this, I actually am pretty inexpensive in the sense that a team of engineers would cost probably about 5 times 70,000 or so, 350,000 a year.
Mm-hmm.
I can finish this project for 350K. I had an estimate done when I first started, and I was told by a $500 million a year research laboratory that it would cost approximately $3 million to build this prototype. Mm-hmm. I've done it for 85,000 in cash and 900 in opportunity cost. I need about another 300,000. So for about 1.25 million, I built a $3 million asset. And once the machines are built, if you were to buy one right after I finished building them, it cost about 50,000, 50 to 70,000 a piece. But so the cost of a high-end automobile or a low-end transport vehicle, which makes them accessible to business. And the idea would be to form some industry partnerships and get the rest of the base development done. I answered your question, by the way. Well, they'll make anything 200 millimeters on the side. It'll cut metal parts and it'll make plastic parts. And at first they'll be relatively simple, but the idea is to constantly have this thing under refinement. And I'm absolutely sure, based on the response that I've got out of engineers here, engineers will play with it on the side. They won't make it their career, but if they can get to it, they'll be able to. And speaking of getting to it, so getting it from the cost, if it's going to cost $70,000 for hardware, what if you built a software equivalent and circulated that so that people could play with it? And a guy in Wales, Patrick Mockridge, has built a game based on this. It's called Makerverse, CubeSpawn Makerverse. And we should be seeing the first release of it sometime in the next month or so.
It's a game?
Excellent.
And it's going to be, the game's going to barely resemble the system initially because it starts out as a puzzle game. But the idea is to refine it. That gives you a AR/VR interface to this. It gives you a place then. An AR/VR interface to the machines means that all the maintenance will occur as if it were remote maintenance. And that collects a lot of data for the AIs that will maintain the systems later. Because everything, including eye tracking, will occur, which will give you attention information. You'll know where the engineer is looking while he's troubleshooting, which means the AI will know what to look at. So all that data will come into the AR/VR interface, and the AR/VR interface is a byproduct of having this game. And the game is also a way to distribute the system to people as a completely digital object so that they can play with it and not have any hardware costs. And then when they feel like committing to putting some hardware in place. Now, there's another entity out of Hungary called Envienta. And are you folks familiar with P2P, Michel Bowens?
I'm not sure exactly what.
Well, his idea is basically to turn the business community of the world into more of a self-aware commons, and to avoid the kinds of problems that we currently have in people exploiting the commons instead of being aware that it is a limited thing. Anyway, he's a speaker, has been, he's a Belgian who lives in Thailand and has been doing all sorts of international speaking, and I think he might have a TED Talk or two out. If he doesn't, he has done the equivalent of a TED Talk at a bunch of different conferences. And so that, for context, P2P, well, this guy Borkis, who is from Hungary, is trying to put together an international hackerspace organization that will keep track of open source templates. And so I've partnered with him, and they have in fact are working on putting a proposal together for, it gets weirdly quick. The Canadian Postal Service has decided that because people don't use paper mail anymore, but they have all this infrastructure, they're trying to put together hacker spaces at their 6,300 locations across Canada, and also become community banks. Pardon?
No, that's very good. I mean, the infrastructure is already there. So to bring down some of that cost, right?
Right. So there's a guy out of Toronto who's working on putting a proposal together in conjunction with Envienta to get CubeSpawn into these hacker spaces. So and the idea would be to bootstrap, though, to build maybe 10 systems, raise $500,000, build 10 systems. Because after the design work is done, building systems is much cheaper. This first one is $3 million. The second one's $70,000. You know, the third one might be $64,796. The idea is to keep pushing the cost down till it approaches materials cost, and then people can build these things in progression out of recycled materials, which will put costs down further. They're using automation, so there's no labor component, pushes the cost down further. There's no freight or little freight. You know, and the idea is to get them down to their materials cost, which is not, they're very expensive. They're probably about a $10,000 system if you just paid for the materials. There's no intellectual property. You don't have to pay for license. You know, all that stuff can go away, which means all those artificial expenses fall out. And
do you think that being open source, it's enough of a safe measure for these systems to not be taken advantage of by companies? And let me give you like a quick example. I was thinking about open source and the servers. So there Ubuntu server, it's used by so many companies to build their servers and services upon. So even though they're open source, their software for the server, from CentOS to Ubuntu and so forth, it is mainly used by companies to increase their profits. Could that be happening if you open source a manufacturing unit to be used again by Amazon and others to increase their profits? So in that sense, may not help the community as much. What do you think about that?
I think that that's inevitable, that there will be a number of commercial applications for this and vertical applications. So if you have a general purpose automation framework and you decide you're going to use it to sort packages, there's no reason not to apply it to that purpose. The idea would be that what I have in mind is actually that there's an embedded crypto in this network, and that a very small fee is collected when something is made or an operation is performed. And I mean, it would be a crypto scale, so it'd be 100,000%. It would be a very small fee, but there are so many fees generated in the course of a day. And then this money splits out in 5 ways. It's applied to, and because we're still stuck in the money system, obviously this system, by embedding it, you can incentivize people to participate who might only have a commercial interest. And so the crypto fee is collected at the machine. The machine then pays that into a foundation. The foundation pays money to engineering, which means you get a royalty for a design if you commit it to the system. So there's a financial incentive for people to do engineering for the system. Marketing and sales both have a fee that they can be paid. If you sell a job and it gets made on these systems, then you get paid a commission for that from the crypto collection. The other part of it is that it funds the entity that collects all the innovations submitted for a period of time and organizes them to re-release them as an update. And the last part of the foundation is an incentive to build underserved areas. Could be built in when you've got, say, you have 5,000 systems in the field. The other thing is, I don't ever want to be a hardware manager. I want to build 10 systems in the hands of the customers. Systems to build another 100 systems has to be self for both reasons. You avoid centralized manufacturing of it, So if it's being deployed in China, it should be manufactured in China. But if it's being deployed in the U.S., it should be made in the U.S. And so the system has to be able to make itself. And there are a lot of things in the supply chain it won't make. Like, are you going to make roller bearings and stepper motors? Not right away. They're complex products that have a lot of nasty side effects. Making a stepper motor is a very messy job. And so you don't want to you're not going to distribute. A lot of the components aren't going to get distributed right away. They'll get distributed 3 or 4 phases down the line when it makes sense to do that.
Right.
As I see it, that's my overall view of this kind of approach. I see that the project side of it and what you may try to accomplish with opening this manufacturing to be able to become local, with materials there and with recycled materials, and open sourcing it so other people can replicate it, maybe even use renewable energies, in a sense that people can maybe you help people by allowing different parts of the world to decentralize their manufacturing, and maybe in the end, as I will understand, just basically help people, because that's what it is about. It's not just about producing stuff, because you produce stuff for what reasons? You have to produce stuff for people, I would say, to help people, not in this society to produce stuff to sell. But although I see this idea as great, like open source and so forth, I'm always concerned how these ideas want to get integrated into this trade-based system that we live inside, and all of these ideas of maybe making a business out of them. I'm always concerned that they will go on a slippery slope, and I'm always like, what would you say about that? Because I see that with open source many times. I see like distributions that are charging for money and encouraging people to maybe sell their software instead of sharing the software. So these bad incentives. What would you think about these bad incentives, and how to take this project out of a theoretical and prototype state into this world that we live in this kind of polluted environment that may transform this technology into something else? How do you see that happening?
I see that an open-mindedness about accepting that there is no ideology. Basically, that as soon as there's an ideology in something, you've created a barrier that that make people not want to use it. So allowing for commercial applications will allow people to use it in ways that I probably don't approve of. But on the other hand, as long as the core of it is maintained as an open source, so it's kind of similar to Red Hat still uses the same kernel, and the kernel is produced for wide distribution, and then Red Hat takes and focuses on orienting towards corporation. That's a compromise that I think is necessary as long as you have a hybrid trade system. But inside of a community, you can have a much more pure installation that uses recycled goods to produce things for people. And if you have an eco-village that is oriented towards, their own food production and, ethical treatment of animals and all of the other things that we all like to see, there are ways that then they can enable themselves to build all of the necessary infrastructure for that without relying on external entities that may or may not conform behaviorally to their ethics. So I don't have to buy stepper motors from a company that exploits their workers if I can get it from a network of people who are in an environment that I consider to be more ethically acceptable. It enables choices. It doesn't prevent misuse. I don't think preventing misuse is a thing that can be built in structurally to a system. You can only build use and accept that it won't. Your question.
I'm thinking about this, and even if everything goes completely ideally, the only one thing that could slow this down is if they completely shut down access to heavy metal. And that's the only way in which you will not be able to build any more circuit boards. You can pretty much build everything else, right? If you can't build circuit boards, you can't build more computers. If you can't build more computers, you can't build any more of these machines. They're not analog, they're digital.
Right.
Because that's the only limitation. To me, ideally, that's the only limitation. Of course, people are going to find ways to use this for bad shit, but I don't think you need to focus on that at all. But perhaps the way you talk about it, where you can use it for commercial purposes. Suppose you if you built in something like crypto. I don't know exactly what it is because I'm not a technologist, but it's just an idea. Suppose you build this system in such a way that the more you keep it open and the more you shift towards the actual decentralization, the whole system gets stronger. Instead of focusing on preventing people from doing things, you incentivize decentralization in such a way that the more decentralized you are, the stronger the system gets. I think that's where it will really start taking. So when Sasha asked, what's the first thing I can build with the smallest prototype? There should be, I think, 3 or 4 things that you can actually build. And first of them, I think, could be like a mini computer, so that you can build it, you can use that for other things.
Right. Both of the boards in this machine, I could have gone with industrial controllers, but we had a Raspberry Pi and a smoothie board. And so, and I've seen some of the stuff going on with smoothie board. I've seen it in applications. There's a product called Ragnar Robot, which is a very high-speed pick-and-place 4-arm Delta robot. And it has switched over to an industrial controller, but they started out with the smoothie board. And they got it up to really impressive performance with the smoothie board. So smoothie board's good enough for that purpose. And then, so pick and place, where was I going with that? So being able to do all of those things and stick to these open boards, then I understand your point that the underlying silicon we don't have any control over. But I think that's changing because there's a group out of Moscow that's doing photolithography at about the 1978 level, doing photolithography in a garage. And so I think that the other thing is that I didn't mention is, so this scales up and down, right? It scales up 1.2 meter, 2.4 meter, big enclosures. There'd be, you can't scale the machines up because the physics don't work that way. You have to actually build different machines at that scale. But it also scales down. So I have some 300 millimeter cubes, 1 foot, 300 millimeter cubes with little tiny milling machine in it. And the idea is micro machining is used now. It's used a lot by the wafer producers and by chip manufacturers. The fabs have to manufacture tiny die cutting machines to make the contacts and the internal traces that go around the chip inside of the package. So there's no reason to believe. I've looked at some of the work that's happening at the University of Chicago with using RNA actually to fabricate protein machines in the cell. So the scale that you can get to is pretty impressive with relatively low tech. I mean, having a cellular substrate, we have very sophisticated technology that nature built. And so, and that technology advances all the time. So I'm not smart enough to build all this stuff. I don't pretend that I am, but I am smart enough to build a box to put it in. And that's basically what this automation framework is to standardize the framework so that you can bring a bunch of processes into the same physical space. And so by being able to get nanotechnology accessible and using the same operating system as the one that's making your fidget spinners, then in essence you've opened the door to nanotechnology also becoming liberated into general use. The idea is that if you have an open source fabrication system that people can get access to, that its limitations are the limitations of the imagination of its users.
Right.
So it's critical to get a system in place. It doesn't really matter what it does at this point. You know, if it
what
makes
about resources, though? If isn't that also a limitation, a big limitation?
I'm sorry, what?
Resources, like materials.
I think anywhere on Earth you can get to all 103 atoms in the periodic table. They're at low concentration. You know, aluminum is the 8th most prevalent material on the Earth. So when I walk around in my yard out here in Texas, about 2% of the soil is aluminum. And
okay, we're talking about nanotechnology here.
Yeah. So all of that stuff is accessible to nanotechnology because you can very specifically manipulate things at the either the molecular level or at at compound level where you can move compounds around. So today, is that possible? No. But in 10 years, will that be possible? I think suppressing the access to materials, especially given that you have so much e-waste floating around. E-waste is a mine. You can mine all sorts of materials out of e-waste, and furthermore, cleaning up e-waste is a critical task to complete. So you could come up with a commercial solution to refine materials out of e-waste that establishes the framework of technology, and then that technology can propagate into this open system.
Fair enough. I get it. But let me ask you one question. What's the minimum smartness a guy needs to be? Guy or girl, basic human intelligence, basic capability, cognitive abilities a person needs to have to take your idea to a town that doesn't have it or a village that doesn't have it and get it off the ground, to build the first thing.
So that at present, get of the mechanical specification, the basic framework, and so there's more to be done, and I do need help with that because there's a lot about the basic software stuff. It has very hard, so it's a relatively so right now it's going to have to be technically adept people to be sure.
Right.
Grandma one, but to get it past this stage, the prototype built, videos, and but someone else could at least build my prototype. That is my job, or me and a team of people, because of course a team of people will make it go fast. Sure.
Did you get any contribution? Any contribution in terms of the technical aspect of it? Any contributions to the project so far?
I've actually had some help from some heavy hitters in the robot. A guy named Sean Edward. You guys have heard of Ross. Ross is with them. It was developed open. And what he did was inside of a research and development facility here, he got it into general circulation, and now he didn't get it into general circulation, but he modified it for industry so that it had a lot more safety. It wasn't cutting edge. Helped me put together quite a bit of the architectural design for this system.
I'm sorry, but can you repeat his name again so I can look him up?
Oh, Sean Edwards.
Okay.
If you look him up in conjunction with Ross Industrial,
right.
He founded Ross Industrial.
Okay.
And then there's another guy that I worked with on this who helped with the architecture, and that was John Morris. John Morris is a core coder for the Machine Kit project. Machine Kit is taking the open source Linux CNC project and updating it to modern code base and adding, removing a lot of the redundancy, a lot of the spaghetti out of the middle of it, and making it work for modern controllers. And they're focused towards the BeagleBone single board computer, but it runs on the Raspberry Pi as well. So,
but you also said that these machines can replicate themselves, right? So that's also an important point.
Well, they can make a significant portion of their own parts. They are unable to fully replicate themselves. They can only reduce their cost at this point by making a lot of their own parts. Getting to the point to where it's full replication, that's phase 6 in my development plan. And phase 6 is referred to as, that's fundamental. And can be dropped as materials from the local use itself entirely today.
Oh, you didn't get that last part. You are interrupting something.
Probe, you can drop core that's like a seed, and it will grow from energy and complete factor. It's a science concept that's been around since the 30s. But it's starting to become achievable. NASA spent a lot of money looking into it for planetary probes in the 60s and 70s and decided that state-of-the-art wasn't possible at that point. It is possible now, but it's a very complex problem that will require a lot of people smarter than myself. The goal is to get as close as possible, and starting is valuable because even if it can only duplicate a portion of it, it's just that you can make it out of junk, which is what I've done with my prototypes. I don't know if you folks have looked. Is there a chat in this where I can drop a link in?
Yeah. It's like transfer.com/chat, and it's a public chat.
Here we go. Here's a chat.
Yeah, sure. Drop some links here because we are also going to put them in the description on YouTube.
Right. Yeah.
Because you talk about many things that we may not have any idea because you are so into this field of open source hardware and open source, basically the automation and automating from manufacturing. I want to say. So we may not know as much, but it's fantastic anyways. It's absolutely fantastic. Or here you can post on there, of course, GT chat. Okay. The roadmap, yeah, I've read a bit. Yes.
And then
yes. Because I was always when I talk to people about these kinds of ideas that revolve around Chrome and so forth, and I'm talking about how through automation and this kind of trade-free goods and services and so forth, we can change stuff. They always say, well, okay, it's nice and you can do that with software, for example. But what about going into the so-called real world? And what I love about this project that you're talking about, your project, is that it tries to merge the two. The online world that's much easier, where it's much easier to create these trade-free goods and services to the physical world, where you can create something like a manufacturing plant that's open source and it can be replicated. And for me, that's just amazing. And I always wanted to get more and more into this, to learn more about this. And I love that you know a lot about this and you are doing something, because it's not only that you are talking about these things, but you are doing them. So that's what I also love about that.
Yeah, Adam is a lot of fun. I've done a lot of that. I spent probably the first 3 online. I got online with this in about 2006.
Whoa.
Or late 2006, and talked about it. Well, talking about it never did anything. And no matter how fast or long I talked, I never ended up with anything. So then I started trying to do it in my at my house, and milling machines are expensive and they're big and heavy and they take up. It's hard to get them to. Can't put them in the living room because they weigh 5,000 pounds. There's a lot of constraints in it. The physical process of putting this together was pretty overwhelming, even though I had some previous machining experience and so forth. And, it's very hard. That's why I think that a digital analog to this that can be circulated, that gives everybody the same benefit as software. They can play with it, they can screw around with the idea, and I think that will lead people into committing to, if you can build a 3D printer, and a lot of people have, you can build one of these machines. And
I want to ask, yeah, sure. Sorry, yeah.
Oh, go ahead.
I wanted to ask you, because you're mentioning 3D printers. It was, I remember when, like, I was making some documentary in 2010 or so, and they were talking a lot about how 3D printers would revolutionize the world, because they can even replicate themselves. So it's like a mini factory, like the lesser version of what you want to build. So I wanted to ask you, because you may know a lot about this, what kind of impact did you see when it comes to 3D printing? What kind of impact did you see about it? Like,
I see 3D printers taking this system over. Laser sintering and a number of other processes are becoming smaller and cheaper. Lasers are dropping in price. You can get pretty high wattage lasers now affordably. And 3D has made that much more accessible than it was. But it's still expensive, barrier. And so it isn't quite there yet. And in industry, they're starting to do some really sophisticated stuff. But again, it's all the usual suspects. Who has the most sophisticated 3D printing capabilities on the planet? Auto manufacturers. 50% of all automation in the world, they have to take these extremely complex that are initially and capitalize on them. So kind of democratizing access to the other motivating factor for the system. If you don't have access to its benefits, what is it to you? Nothing. Exactly. And so the automotive industry has half of all automation. The electronics circuit board assembly industry is another 20%. And then it's pharmaceuticals and packaging. And there are some fantastic technologies that will come, but they won't come to the right people. They will come to some big corporation who will then use them to continue exploiting everybody. Unless we have a system where people can actually have access to these capabilities on a personal scale, on a human scale. Where dollars to get into it. That's a pretty so building these relatively primitive small initial machines is a little crack in the wall. It's an open door to get into building more sophisticated machines that leads to stuff like, I don't know if you folks have heard about the Computer. It's a project in Scotland. A Scotland researcher, he started putting it together probably 10 years ago, but it's actually starting to reach commercial stage capabilities now. And the idea is to be able to print pharmaceuticals. It's a 3D printer for pharmaceuticals, and it's not really a 3D printer. What it does is it prints reaction chambers and has a whole bunch of basic chemical compounds that it mixes together with dosing pumps. And the idea is to be able to combine and create extremely complex chemical reactions by software, under software control. And there are some 3D printing projects where people have printed reaction chambers to allow you to, say, produce aspirin on your desktop.
Wow. So basically, for a very small town, if somebody buys a computer and there's somebody who can use it, you wouldn't need a pharmacy that would go to big pharma to buy basic drugs. You could probably synthesize them in that very small pharmacy, right?
Well, you end up with a much more Star Trek future where, you go to the auto dock and you go to the auto dock and it recognizes who you are and says, yeah, you're out of whatever, here's your dose. And that's the kind of stuff that can be done from basic chemicals. It doesn't have to, there are no restrictions because no chemical is a, aromatic chain. So, I mean, there's an awful lot of stuff that's based on carbon. I mean, that's the basis of life. So So a Chon printer that can handle those 4 things and combine them in the right way, catalytically or whatever, you have access to pharmacopoeia. Those are the kinds of things that we can let big pharma sit and still pay $300 a couple of pills. It's a kind of choice going forward. Who the technology that makes society rich?
Right.
Or a few gatekeepers. And so,
right.
Establishing the technology so that people can is the first step in a process to have control over their own physical lives.
Which is going to be, of course, always a huge challenge in this society, to not get this kind of technologies polluted in one way, in one sense, or on the other hand, to maybe not even allow such projects to grow because of funding and.
Well, right now it's under the radar. Nobody even cares. The
only thing I can think about is why the fuck are we not funding this?
Well, yeah, I ask myself that question fairly often. 13 years into this, and I've pitched it to all sorts of finance weenies, and
Did you go to Silicon Valley?
Oh yeah, I went to San Jose. I was out there for 3 months, and I talked to everybody and their cat, and all they basically said was, "So, what do you got in Bitcoin?
Yeah,
what kind of technology you want to make?" And it was like, and we went out there for a Bitcoin business, but it didn't get funded either, because our ideas were totally hot shit in December of 2013, and they were completely ordinary, yawn-worthy ideas in July of the next year, because everything moves very fast. But I talked to the project while I was out there, and they all said, "That sounds really heard from again."
This is fucked up. So let me ask you something like really basic. You said you needed $300,000, right?
Right.
For a town of 1,000 people, that's $300 a head.
Right.
How long will you take, say just roughly, how long do you think your project will take to use up that $300,000?
About 4 months.
Okay.
We'll complete the prototype.
Okay, so per month, that's around $75 a head, right?
Yeah.
Now, how many towns do we know that where people have $75 a month, 1,000 people in that town have $75 a month, just lying around, disposable income?
Probably any town in California.
See, so is there a way to pitch to those people and you can get something for them? Unfortunately, this has to be a trade, but do you think you could get that off the ground? Your $300,000 comes over 4 months from 1,000 people plus minimum, I'm just saying, over 4 months. And what can they get out of it?
Well, as early adopters, I mean, you could...
not value for their money. I really hate talking about trade like this, but I'm just asking, what will come out of this? Not for them, but basically, what is this $300,000?
Oh, they get a bunch of YouTube videos of the machines working together to perform operations.
Right.
There's a deliverable in the sense that you can build a lot of promotional material if you have a functioning prototype. And that would be what the prototype is for. The prototype serves 3 purposes. It's intended to create promotional materials to push the system in front of more people, create exposure. Secondly, what it can make, which is relatively limited, what it can make has appeal to various types of industrial manufacturers. It can do second operation to do trim out. It can do some actual useful things. So it has promotional value. It has utility value to create industry partnerships with people who want to turn it into something else for their purpose. Add different modules to make it do something useful for their business.
Right.
And if you have a prototype, what would be the next step?
Step after this one?
Yes.
Complete. The expand the template so that it can actually provide a food system. That was with it is to FarmBot.
Okay, you interrupted a bunch of times.
Yeah, that was.
I didn't get that. If you can repeat, please.
It was FarmBot.
We just got FarmBot.
FarmBot.
Okay.
So you can make FarmBot.
So FarmBot to grow food.
Okay.
Or so food production systems are something that would that so that this system could make them is sort of getting the prototype complete. The prototype, because the idea is to get developers to make this system for their own purposes and to add technology to it.
Okay, I know FarmBot.
Okay, so basically, if you have to start, say, for now, an example, a small trade-free community somewhere, the first thing we can do is these people can start growing their own food. Using one of their machines, they can make FarmBot so that can automate their food production, leaving them free to make, additional trade-free goods and services, right?
Right.
And how much is that going to cost? Just for now, because we're living in a world with money.
How much is the second phase of development going to cost?
How much is it going to cost for me to get from nothing with a piece of land to have FarmBot on it with 3 people? Just roughly.
The FarmBots themselves will be about an open source project that it's got nothing to do with me.
Mm-hmm.
My machines can make them.
Right.
They're also open source, right? They're open source hardware and software FarmBot, right?
Yeah, they're also Raspberry Pi, and so.
So basically, you could take their templates, in a sense, and then build them in theory with your production manufacturing plant. Like, would that be possible?
Right.
So that's where your project comes in, allowing such other open source, also allowing such other open source projects, like FarmBot, to be replicated. Not only that you can create new things, but you can take whatever it's already out there and build with your project. So I think that's a new and interesting, a very new, for me, it's a new approach. I haven't heard of this. I've heard of open sourcing the production line or the manufacturing, of course, of certain processes or certain goods and so forth, but not like this modular idea. So that's what I love about this modular idea, because it's a lot more flexible in what it can build. Basically, that's why you think yours it's different. Would you say from what you see on there?
It's a jump, so it's adapted by your imagination.
Right.
The system, you put a system in a community. I actually more formal plans for phase 2 are that the phase 1 prototype accumulates all the templates for the phase 2 production system, which then is capable of creating stuff for food systems, station machines, and drones, and whatever the hell you want. It really is limited only by and what the focus is, because somebody has to go through the process of designing and building the template so that the machines can turn it into a physical thing. So where the engineering focus is what it will be capable of producing. It's a general purpose system, so it should be able to make anything given the space constraints. I'll put this link in because this actually I have the whole series of these, so phase 2 just kind of expands the capabilities of the system, and then phase 3 is actually the food production stuff. But systems into community, barrier at first is cost, $50 each, depending on, and the first set of systems will have to be made somewhere, sent to a destination. But after they're established, and that's not true if you're making them like you're in Germany, right, Theo?
No, I'm in Spain.
I'm sorry, what?
I'm in Spain. I'm in Spain.
Oh, you're in Spain. Okay. Well, same general thing, because in Europe you have access to the full spectrum of resources from for industrial manufacturing, which means that this system could be created anywhere in the West. I think if you were in Botswana, it would be a little more challenging.
Right.
And that's the hard part, is that in rural Asia, even rural Asia doesn't have access. If you're in Vietnam, getting the parts for this might be a little bit more challenging. And if you're in Kazakhstan, I don't know.
Man, you don't have to go that far. If I step 25 kilometers outside the city from where I am right now, you can't get any of those parts. You can't get panels.
Right.
It's very difficult. But I get what you're saying, and your system builds the tools that will build the machines that come after, right?
Right. And 25 kilometers from where you get the parts, if you put one there and in time, you will have those. The machine has to go through some additional evolution before it's capable of making mechanical technical parts. It can make mechanical parts in the first stage, and then each successive stage it becomes better. But that's sort of getting off in the weeds, because really the goal is to accomplish this first prototype,
right,
and get it so that it can be filmed and used as promotional material, and say, and you're probably going to have to, in the process of promoting it, you're probably going to have to say, this doesn't do it, but it leads to this and this and this. It's a vision. It's not a certainty at the early stages.
When it comes to software being open source, you can always, of course, upgrade it and upgrade. Like Linux kernel, probably the Linux kernel went through a lot of modifications over time, but that's a lot easier than upgrading the hardware part of the machine. So
that's sort of the point of this. The point of this system is that the idea is that we can do most of the upgrades are going to be mechanical and physical changes to the system, which means that these machines can create their own upgrades and create extensions to themselves. So if you want to put a new machine in place, there might be a short bill of materials of things you have to buy, and the rest of it can be made from stock materials. So that's where I think this differentiates itself, where these machines can upgrade themselves in place. This is, I've referred to this thing as it's an atom compiler. You can turn them into necessary means to create additional things. And you can chain your way towards goal objectives that are not possible on the preliminary machine. So it's software behaving hard. Earlier about the open source projects. Using this thing is essentially it's the Star Trek Borg of open source. Everything gets assimilated. May have something to contribute to.
If you were to imagine this ideal world of manufacturing, how would that look like? Forget about money, because money doesn't work all kinds of other trades. How would you see manufacturing into this kind of ideal future? How would that look like?
Well, the ideal future would be that your weight in the kit is tied directly to a system that will nearest those modules will have
So you're interrupting so much that I cannot.
Oh, I'm sorry.
Understand.
It's all good.
In an ideal world, everyone would have off an internet.
What's that?
Didn't catch that, Chaz.
You can try now. Let's see. Maybe it will work.
So
how would it look like?
When you throw something away, it goes to recycling.
Right.
And then that recycled material goes to the local factory. The local factory produce whatever people are at immediate neighborhood. So complete circular implemented right at the from the delivery chute. It's through there are very little virgin material into that system. Something like 80% can the materials that are thrown away. So that's in an ideal world of manufacturing. That would be the goal. Would be to produce goods from waste using ambient energy under complete automation.
Why should the local manufacturing be? Why do you think it's, or is it more useful than maybe centralized manufacturing at large scales? Why would that be in a world that where, let's suppose we're not incentivized to make as much waste out of products? Why would that be an advantage to have localized production?
Well, one thing is that materials costs are lower because the materials are already there, so they don't have any embedded freight cost.
Right.
And the other thing is, if by using automation, there's no labor component to your product. It's purely digital, which means that there is distribution cost. You can get your product anywhere in the world. So, from a commercial temporary network, there are advantages work now. Now, in an ideal world where goods become so cheap, no longer bother to charge for them because they're local energy. All you're charging full line, and maybe not even that for a lot of it would be. So I do a unique sculpture designed to you. That legitimate in a world. Not everybody wants to have that sculpture in there.
And for me, you're interrupting so much. I struggle to understand. Is okay for you guys?
For me, it's fine. Yeah.
Little
I
bit.
can't hear very well.
Little bit, but I get the gist of it. You know, it's quite obvious. No transportation costs, so therefore no embedded energy costs that come from transport. It encourages recycling and reuse, therefore the circular economy and all of that.
Okay, yours is also really bad for me. Maybe it's something with mine. Okay.
That's it.
That was my
everybody has to type as fast as they talk.
Right.
Don't talk that fast. I was thinking that in this kind of ideal, let's suppose in this ideal society where we don't have to deal with this invention of costs in terms of money, maybe cost in terms of energy and materials. Okay,
right.
But in this kind of society, why would localized manufacturing be more efficient than maybe a centralized one that, considering the transportation is based on renewable energies? Why would that be an advantage to having more localized and centralized, but maybe like the bigger scales?
I think you're asking the thresholding level where it makes sense, because if you're manufacturing things within 100 yards of the person who's using them, how is that better than doing it within 5 kilometers? there probably is an argument to the degree of centralization. Service space is the right amount of people for one factory, or is it 10, or is it 100? The answer to that question: how centralized is it? So the size of the facility will be proportional. I think the problem is manufacturing now, where you produce hundreds of millions of units at a single facility. Well, it's obvious nobody in China needs those hundreds of millions of units, which means that there has to be international trade to keep that factory operational. So that threshold is too high. It's too big. Whereas having a factory for every 10 people, well, that threshold is probably too low, because that doesn't make any sense. So there's a balance to be struck, and I think that will sort itself out. If you make these factories and you put them in a community, and there's long waiting lists because nothing's getting done in time, well, clearly there's too many people. You need more factories. But if you, on the other hand, if the factory only fires up once a week, well, it's too low.
Right.
No, that's where the whole modularity thing is so important. It can be scaled to the exact need. The smaller the module, the more precise we can get.
Right.
Well, this is definitely a really, really interesting idea. It's absolutely interesting, because I was always wondering how this can look like in like a real project, because I've seen a bunch of just theoretical designs. It's not like those are it's not like those are not important, but also to see someone who works to make something of this kind real, that's extremely fascinating. And I was curious, like, how did you, like, where is the connection between whatever you did there and these kinds of projects? Like, how did you come across Trom or other projects? Like, where did you get inspiration from, like, I don't know, the Venus project or other projects, or you came up with such ideas and then you kind of came about these kind of projects? How is that connection there?
It's enlightened self-interest.
Yeah.
When I was building, so the first 3D printer project was the RepRap project. That was what open source 3D printing. And the RepRap looked very interesting, but it also, the original design also looked kind of janky, and it looked pretty kludgy to me. So I kind of held off on building one. I wanted something better than that. And while I was holding off, but I was still really engaged in the project. I was really interested in chatting with a lot of people on the RepRap boards and stuff. And I thought, well, that would be great, but it would be also, the 3D printed plastic parts are pretty crappy. They were low quality. They weren't great. And so, what if you could build the prototype for the machine how can I make this process recursive? This process either, because the first printers weren't very expensive to build, but they weren't very good quality. And if you wanted to build a good quality printer, the choice was, I can build this $400 or $1,000 RepRap, and it's kind of crappy, or I can go look on the market and the prices start at $150,000. There's nothing in between. And so that led me to the idea that, well, there needs to be something in between, and prototyping shouldn't be so damn hard, because when I started to prototype stuff for myself, it was extremely difficult. So I wanted to come up with an easier way. Well, what if you could automate some of the stuff? What if you could do this and that? And one thing led to another, and it is 13 years later. I've had a little bit of time to think about this. So during the intervening 13 years, a lot of stuff has emerged, and it also turns out that this is like at the nexus point. Shipping, energy, labor, social issues, all of those things converge at one place. The world economy is approximately $86 trillion. Of that 86 trillion, 35 trillion of it is manufacturing. So what do you suppose drives all the biggest issues in our society? Well, it isn't gaming. It's manufacturing. And manufacturing is boring and off-putting. You talk about manufacturing, everybody in the room falls asleep. You know, if I were a bank robber, that's what I could do. I could just go in and talk about manufacturing, and then
right, yeah.
So how did you come across this kind of projects, though?
Well, I started building machine, and when I built a machine, problems, and so I tried to find solutions to the problems. And I read a lot. I read 16 hours a day, left to my own devices. So I read a lot of articles, and that means my head is full of a collection of totally matched statistics. So patterns started to, we have all this shipping. Oh, manufacture wrong. What if we manufactured right? Well, and then quality. Inequality is a big problem, and so somebody made their own stuff locally. Nobody could deny it, and so questions started. Project came from the long. What is the problem? What is the solution? And that a well-defined problem is because specifications hold the answer.
I struggled to understand for the past
that
15 seconds.
The last part was a little bit.
I'm still James.
I'm sorry.
Yeah. Okay. For the past
it's all good. It's just internet.
Last idea. You're talking about inequality. You said that it's something about inequality. I didn't get that part.
Oh, okay. So it addresses inequality because if everyone makes stuff for themselves locally, no one can deny them access to it or extort extra money from them for it. So inequality is impossible in a society that has access to making its own stuff.
Would you guys agree with that?
I'm sorry, what?
Inequality, it's impossible in a world where people have access to manufacturing their own stuff. Would you say that's
impossible?
It definitely takes the dent out of inequality. It makes it less. It makes it more difficult for inequality to manifest.
Yeah, I would agree with that.
Yeah.
Sure. Yes. Well, so you're thinking about Noam, you want to say something?
Yeah. Well, they don't like the means of production, so I don't know the means of production. That way, they can produce what they need.
Right. Well, means of production are widely available, but there are all sorts of barriers, all sorts of invisible barriers to them. And local control of manufacturing removes those barriers. It doesn't remove the barrier to intellectual property because you may not know how to make something. You're going to have to ask somebody who does. So right. I don't know that designs will ever be completely free because somebody has to have domain knowledge to create solutions. But all the universal problems, clean air, clean water, food production, transportation, all of that stuff, that's going to be pretty hard to keep a lid on. Exotic medical technology, yeah, you could lock that down and make it hard to get to for a while.
Right.
For a while.
Though even when it comes to food, they're patenting seeds, for example. So that could also be a problem.
I believe that's fast. You have general access to biological knowledge. Why not have? There are people who will do that. There are people doing that now. I don't think that kind of control is sustainable. I don't think you can keep control. Biological systems provide way too much information if you just step out the door and breathe.
Right.
Are you also all familiar with open source ecology?
Yeah, I talked to Martian quite a bit back in about 2009. We had several phone calls and lots of email back and forth. And I thought our goals were very similar, but our path to those goals was very different. So
he's basically building tools for people to be able to like track even tractors or stuff like that, to be able to use.
His focus started on the agricultural end, and I didn't agree that was where I noticed that it shifted quite a bit because he's doing mini factory seminars now. So we've ended up in the same place, but I started on the mini factories end of things because I thought that it's a geometric progression. It almost doesn't matter how long it takes to get this first step done because it's a geometric progression, meaning as soon as this is done, then the next step starts, and the next step will take less time. And the next step is facilitated by this step. And that happens for 5 or 6 cycles. And then it doesn't matter how hard it was to get it started because the snowball is now rolling at 70 miles an hour.
Right.
So getting through this first step is, like I said, that's my job. I always do the hard thing first. And so getting this to work is critical. Once it works, I'm out. I'm gonna coast for a while because this is kicking my butt. This has taken 13 years, and it's been an uphill fight the whole way. But get the prototype running, get some videos out there. There's a lot of smart kids that can do shit that I can't do. Let them do it.
This entire maker movement is quite fascinating. And did you get into that with your project more and more? Was like there are these maker fairs and so forth? Do they provide a way for you to get more known out there with your this kind of project?
I did a little bit of that, but I find the idea is a little too abstract. I've had a very hard time. And when I talk to financial people, there's this huge gap. I'm doing research to build a prototype. The prototype leads to commercial stuff, but it is not a commercial thing in itself. And so they get rid of me. They dump me right away.
Right.
You know, I can't say this will be a product.
It's not something they can sell. They can make it to sell with your technology, but they can't sell the technology itself.
They could sell services in products, probably. That's the best that they could use. You know, like other companies use Ubuntu servers to run their own businesses, even though that's free and open source.
Yeah. And when it gets to that, when it gets to the point where it's productizable and commercial, then I'm sure it'll be very popular. But it's not quite there yet, so it isn't popular. I never tried to be the popular one, and we can see why.
No, you shouldn't be, but unfortunately, it's been kicking your ass for 13 years now. You know, I just keep coming back to that. Why the fuck are we not funding this?
Yeah, right. No.
But this is eyeballs. The whole point is that it has to get in front. I do have a Patreon, and it's raking in a amazing $170 a month. You know, which on a hardware project is a lot like a nickel.
Right.
Especially in the US too.
But you know, it's better than nothing, and it does show that there are enough people that have the insight that if I got the message out the right way, very likely it would be funded. I mean, I can live on very little. I can live on probably $1,000 a month, which in this part of the country is, you know, that doesn't even pay rent.
Oh, geez.
But the thing is, I can't build hardware on $1,000 a month because no matter how I slice it, I end up spending, you know. If I paid for all the stuff that I use at the machine shop, because they give me free aluminum, they give me free industrial controllers, they give me free wiring, they give me free stuff. But all of that stuff probably is $10,000 or $15,000 a month if I had to go buy it. So it quickly, and you know, there is so much junk in the world. Any metropolitan center there are manufactured perfectly good machines today. And takes advantage of that, but those sale value either. Enormous intrinsic, taking advantage of the intrinsic value place throws away. So that's where I'll.
Yeah, you're interrupting a bit.
Cutting out again.
So I'm talking to myself.
Yeah. Yeah, I see that in our Trom-Cast.com/chat, Alex was posting all kinds of links about other projects that are building open source hardware. So I was thinking that it would be cool to also maybe we can at one point make a Chromebook about how to build stuff in this open source way and getting inspiration from CubeSpawn. And your project is at cubespawn.com. And is it active? You keep it?
Oh yeah, it's pretty up to date. The game thing is kind of the big deal that's going on right now. Hardware development has been suspended for probably 3 months, but I'm still poking around on getting electronics running and that sort of stuff. So it certainly hasn't stopped, but the actual cutting metal is stopped for a little while.
Right.
What were you able to, like, you say that is this thing that you're building, this is functional? Like, what can it do now? And we lost you?
No.
I cannot hear.
Maybe?
Oh no.
Hang on. Oh yeah, we did.
We did.
Oh,
Give me
no.
a second.
Completely no.
This is the first Trom-Cast that I'm not the one who talks the most. Probably. Because James knows so much about this subject, it will be that's how it should be. We should learn from people who know a lot about this kind of subject. So I'm quite fascinated about all of this, and he knows a lot about in things that I don't know that much about open source hardware and manufacturing. So I think this is quite fascinating.
And it's so in-depth and technical. So in-depth and technical. And he's on the front lines of it, doing it every day. Wow.
Yeah, for some people might be overwhelming because this is like new thing. Is like, okay, even I was like, I don't know exactly what to ask. I would rather listen to see what this is all about because he knows a lot. So I would love to also make at one point maybe either make a Chromebook about that, or for a new documentary that I want to make, maybe I want to reboot Trom to make the second part of Trom documentary. I would like to talk about such things, even like if that would be possible to even interview these people.
Yeah, definitely. I mean, that would be something I would definitely watch. To get them all together if they can, and then see them bounce their ideas off each other. It will be so fascinating to watch because I personally haven't seen a video like that. I've watched documentaries where people talk about these ideas and you have individual interviews, but to see these people not only individually speak about their projects, but also how these projects can work with each other, because we do have it's very clear everybody has that common goal, moving away from this trade-based society to something better, more efficient, and more sane, basically. Just more sane.
It's great for people to see something that's actually happening because they will. It's good to showcase them examples, like even in the prototype stage, to see that, oh look, this guy not only talks about so much about how we could potentially decentralize manufacturing and transform the manufacturing landscape, which is something very difficult for people to imagine. Like, how the fuck can we do that? Because just big companies make big factories and they make big toys. But he also makes something that works, and he does the physical stuff too. So I love these kinds of things.
Yeah,
because I think that's powerful to get the message across.
Isn't it so obvious that it's not just an idea? There's somebody out there doing this. Somebody is actually attempting this. Very exciting. More people should know about it.
What do you guys
to be
think?
able to show,
fashion,
like to be able to show something, in the material world, that you can actually make this kind of open source hardware. That's great. And I like this idea of, recycling a lot, moving it closer, moving it back to recycling.
Welcome back.
I'm back.
Yes,
You're
yeah.
back. Okay.
Your sound is a bit weird.
I got it.
But
I got it.
yeah, okay. It's Cody's fault.
Oh my.
Fix it, Cody.
I can't fix it for you guys, but I can fix it for the stream.
Okay.
You just gotta toggle his volume.
Can we? Yeah. Just toggle his volume. It's too high. You have like the three dots, the menu thing in GT. And
Here's the thing.
what did I ask? I was asking.
Good question.
I was asking. What can you, James? What can you really produce now? Can you produce what kind of things? Just what kind of things?
Since I'm in the middle of the prototype, not much. I have a 3-axis milling machine and I have a 3D printer. And the 3D printer is a pretty low feature 3D printer because I built it for the system, and the system has moved so slowly that I've actually been obsoleted. My designs are almost obsolete already because things move so fast. So I built a printer about a year ago or 2 years ago. And so a lot has happened in the 3D printing community since then.
Right.
Yeah, that was another question of mine. How do you keep up with upgrading the hardware on such machines?
Well, that goes back to the crypto scale fee collection and a institute to take all the innovations and more official ways.
Could that be done purely by code? Could it be done purely by computer code, just theoretically? That wouldn't need people for to,
I got bankrolled by, but I didn't get what?
Repeat, Chaz.
Right. Do you think this foundation could be managed entirely by computer code?
Yeah, I'm still not getting it.
Yeah.
Wait, I'm going to type it out.
Oh, he's got to type it out.
And if anyone has any questions, they can use the chatting to YouTube live video or Trom-Cast.com/chat.
No.
I was also going to direct you all on that CubeSpawn Phase 1 link. If you go to that link and scroll to the bottom, there's actually a picture of the machines.
Okay.
Yeah, absolutely. But you can also
Got it.
fire that up.
Got it. Oh, yeah.
And your idea is also to scale it up eventually to up to even mining machines, right?
Right. The long-term plan would be, now obviously I said I'm going to quit as soon as the prototype's done. That's not true. I'm going to focus on more specific things, though. Where this is an effort to establish a general purpose system, and then I'm going to narrow my focus down to work on specific kinds of problems. But I think the community at large, once there's a little bit of adoption, a little bit of attraction, the community at large will take on all the things that are important to them, which will be food production, transportation, all sorts of stuff that I'm not probably likely to work on. And the idea that building of infrastructure so that people can take ideas and get them into general circulation, that will kind of run itself in that people will come up with ideas. Now, putting standard releases of updates out, I think that's going to require some centralized coordination, even if it's not centralized physically. There will have to be a group of people who takes what people are submitting into the system's templates and incorporate those things into standard releases, so that, because everybody knows if you've dealt with software updates, one update can break your whole system. One bad update can break a whole network. So a bad hardware update, can you imagine the chaos when you build a machine that doesn't work?
Right.
As an update, that's a stupid idea. So having some sort of oversight on updates, at least for a while, until our AI masters take it over and make it better, is probably a good idea. And somebody's going to have to fund that. So that's why that crypto scale fee being built into items provides a mechanism to do that. It might not be the best idea, but it's the idea we have right now.
Right.
And I'm willing to cede control of various things to anybody that wants it, because this is not making me rich. This is not making me famous. I don't particularly want to be either one of those things, but I do want this to get solved. So,
yeah, just imagine how much potential we could, as a human species, have if people could be more like James, Because he talks about stuff that I'm like, even for me, I try to keep up to date to such things. It sounds, I would not know where the fuck to start to build such a thing. And he's doing that there. Imagine how many people are out there who would be able to do such things. So when people ask, like, okay, but you're talking about this kind of society where you make trades obsolete, meaning that people will have access to their and maybe many of their wants without giving anything in return, like money or cryptocurrencies and so forth. How could you build that, or how could that work? But you see, now you have a small example in James, for instance, who does such things, that he's not only passionate about such things, but he's knowledgeable. If he had the support that he needs, he talks about financials because that's what is in today's world. It's just money, because it spins things around. But if he had the support, not only in terms of resources, but other people contribute. Imagine if he managed to do all of this work by mainly his own, as far as I understand, how much we could do if 10 times more people or 100 times more people could get involved and build such things that we might consider as being science fiction. Some people talk about even this manufacturing, like we also talked about a little bit in terms of like nanotechnology, eventually to build not only, maybe not atom by atom, but maybe molecule by molecule, to build all kinds of stuff. And you might think that's just far out, but we will probably reach that point too. So we will go in extremes in terms of like what we are capable of in terms of manufacturing. However, because of this society, we keep things in place. It's the same as they are. In the future, if we can build nanotechnology, probably Nike will build shoes with nanotechnology, and sell those shoes. It'll be the same fucking, waste all around the world, even if it will be nanotechnology. So we need people like James who say, look, we should not only decentralize such things and be making them open source, but have as far as I understand, a greater purpose here of not in ideology, maybe you may say, but to help others, to provide a means for people to build their own stuff, because that in turn might change people and communities and eventually society to become less harmful in terms of behaviors, to not hoard as many resources or maybe make as much waste. So in essence here, I'm extremely excited to see someone like James, and James, I think I will want to work on a, I don't know if you saw Trom documentary or you're familiar with Trom materials, but I think you contacted me, I don't remember, but I would like to make another documentary soon, and I was thinking that it would be interesting to even have you interview for a documentary or something, if that will work, but I'm very excited because you are from a domain where I don't know much about in terms of like the details. You should have a voice in that regard. You should be more popular. Even if you don't want to be popular, you should be a bit more popular somehow.
Yeah, I'll go back to my closet.
Are you familiar with these ideas like the Venus Project or whatever we talk about in Trom?
Well, I really respect the Venus Project and the Zeitgeist movement. I think they're both great. Unfortunately, they don't provide any kind of a roadmap to execution. They talk about
all these really high ideals and how we could get to a better society, but what's step one? What's step two? How do I get to, what bus stop do I have to get off at to find this stuff? And there is none of that. It's all with Jacques Fresco, sure, genius, really had some great ideas, beautiful architecture. How do you do it? How do you do it, Jacques? Where do you start? And there really was no way to start. And the other problem is that, we're going to build a city, this fantastic city. Well, it's $1 trillion project. Where do you...
Yeah, and there are a few issues, with this idea.
We still live in a money world, and you've got $1 trillion first step. I'm not in. I appreciate everything you're talking about. It's all good stuff, but I can't do it.
Right.
And so I've tried to step that down. I'm a guy who has been doing this, if I didn't have the support of my better half, I couldn't do it either. But even at that scale, at least it's achievable by a single human being to make some sort of progress. And I could do with a lot more support, because then I think I could do more. But I've been at this, as I said, for a long time. I've been at this full time for 5 years. And to be honest, I'm getting a little tired of dragging the plow by myself. I need some more horses.
Right. Okay, so if you needed more horses, what would be like the necessary educational backgrounds that would really kind of help push this in a efficient, fast direction?
Right. Well, I think young, enthusiastic people is one way to go, where they're willing to learn. And the other way is old guys who have experience in industry and are retired and self-sufficient. Because a lot of the old engineers I talk to say, yeah, that's a really good idea. You're 10 years ahead of manufacturing. And I've got one guy who's volunteering a little bit of time. I got another guy who's, he likes to talk, but he doesn't do a lot. But, that's the way it goes. That's the way it goes. What's that?
No, that sounds just like me. Who is this guy? We could be friends.
Likes to talk, doesn't like to do much.
Maybe Shaz had the background to get involved with such a thing if you had the time, right? Shaz, do you think that you have the background to?
Dude, first of all, I'm really dumb kind of human being. Nothing that I ever try has ever succeeded. But I do like thinking about these ideas and imagining possibilities. And with James, what you're doing, it's so encouraging to realize that these are not just ideas, and there are real people really working on these things. And for the doers out there, that's one reason for you to be popular, James. There are other people like you, and they need to know. That's how you get more horses.
Right. I caught some of that.
It's difficult. It's difficult. Just I don't know what's up with your audio, but it's also difficult to understand. I don't know. It looks like you're talking from the other side of the room.
Maybe even the other side of the planet.
Yeah. Yep. Actually, yes.
So James, can you hear me?
I can now.
Okay. So an electrical engineering degree, a mechanical engineering degree, and some coding expertise. Would these three basic qualifications sort of help people get into what you are doing?
Yeah, or even just an enthusiastic amateur, because a lot of this stuff is programming Raspberry Pis, programming, a lot of people have self-taught in that to a degree that's, very capable.
Mm-hmm.
So, and that's the other thing is, why did I use a Raspberry Pi and not some PC-104 stack that nobody's ever heard of? Well, because there are a lot of people who understand there's a big community around it. everything has been chosen for the size of its community. I do all my drawings in SketchUp.
I'm actually super good at SketchUp. Okay, I don't want to brag, but I use it every day.
Yeah, and I can make no guarantees that my SketchUp drawings are that great, but they convey the impression well enough for somebody else to machine it, which...
Right, yeah, I mean, to take it from there to CATIA or, SolidWorks or something, it should be easy once they understand. I mean, to get the concept out, SketchUp is amazing.
Right. And all the drawings are in SketchUp. They're all on GitHub. The drawings that I've made so far, at least for all the stuff that's not an experiment. And the weakest part on my side is coding. I've hacked things together and given them work. I have 30 years of IT experience, but I've never programmed. I wrote lots of programs when I first started out. They were in pure machine language. I didn't even use an assembler. I mean, they were hand-assembled machine language. So I understand programming concepts, but high-level languages are foreign to me for the most part. I've done a little bit of a Python. I've written some stuff in Python, but I would not show it to anybody that knew anything about programming.
That would be probably the easiest part for people to help with now, or the most useful for coding.
Yeah. Coding is critical to make this work, and it's my the weakest area. So building hardware and then hammering together shell scripts and other gruesome techniques to get things to happen, that's kind of where I'm at. And there's a bunch of industrial architecture design stuff that's already been done for this problem. This problem is solved. It's just a matter of gluing the open source pieces together to get the control architecture working. And it may not be the best design for that control architecture, but it's not bad because it was put together by some people who know far more about this than I do, that are kind of leaders in their area, leader in the field. So I have a great deal of confidence that, it's just a matter of having enough expertise to get this first step to the endpoint, and then then a larger community of people with real domain expertise can advance it, and there will be plenty of incentive for them to do so because it just has too many positive dimensions. And I don't claim credit for this. I put the idea together out of other people's ideas. That's the way innovation happens.
That's how civilizations are built. Actually, you build on top of what was built earlier.
Right. Standing on the shoulders of giants, that quotation, well, that's because I have 200 years of geniuses' efforts that I can walk around on top of. And, I get started off at a pretty high level without having worked very hard on it.
Yeah. If you guys have any questions for
Yeah, I have one. I have a question. First of all, I'd like to say that I'm really enthusiastic about this project. I think it's a great idea for all the many reasons we already talked about. But I'm worried about how to make it where that people really use it. And we already talked a bit about it. But I'd like to know, what do you think would be, you said the initial cost would be like 50 or 70,000 euro or dollar to have the first parts. Is this first part one of the cube? I mean, what do you call the first part, and what would you get for this 70,000 euro you're talking about?
So let's see if I understand your question. Where would you start and how would you pay for it? Is that, or if you paid for it, what would it do for you?
Yep.
You said, I think you said that. So did you say that the first part, when you buy it, would be $50,000 or $70,000, right?
Yeah.
What do you get for this price exactly?
You get 14 machines that work together. to produce, at first, a very limited range of goods, and then progressively they're a general purpose manufacturing system, so cutting metal, printing plastic parts, and fitting those assemblies together is all stuff that the system can do right out of the gate. Or it can prepare stock materials for another process if you already have a factory or a shop of some kind. It's a pretty expensive solution for what it does at the first step.
Yeah, I mean, it's is it do you get the delivery costs in this $70,000, or it's just like the thing itself?
The thing itself.
Yeah, okay.
That's actually probably the manufacturing cost is a little more than half of that, which means that if you built it yourself, you could probably do it for between $25,000 and $35,000.
That was my next question. And is it feasible for someone with little to no knowledge to build it itself just from the blueprints and the good explanation you're giving?
The goal is to have good enough documentation for you to build it. That documentation is not good enough yet.
Okay.
But you hope that it will be feasible? I'm talking about the very first one, of course. Like once you have one, you said it would be possible to replicate it from it, not fully, but mostly, and you're giving
we can get it to make a lot of parts.
Yeah.
So producing parts for the second machine's actually quite a bit cheaper than the first machine.
Right.
But it is possible for the first machine, because I know about farm bots. They are selling just their parts. They are either selling the whole thing, or they are selling just their parts, or they are just telling you how to do it. And I don't know if it's really possible to do this first machine on your own. The first one I'm talking about.
Oh, yeah. There are parts that you would probably have to buy. They'll have to be made centrally. For instance, the milling machine has a couple of parts in it that are not possible to make on the system because they're too large. There is no way to get the system to make those parts. But, the goal is probably to go through some redesign. This is the first prototype.
Sure.
So there will probably be some redesign so that we'll try to push that 80% of the parts on the system up to 95% of the parts.
Right.
And the technical stuff, the motors, the electronics, none of that can be made on the preliminary system. Well, that's a lie. A little bit of it can be made. You could do circuit board milling and you could do some other stuff, but it's a chandelier and an outhouse. It's the wrong answer. A lot of that stuff you can simply go buy in the market, and it would make more sense for the earlier machines. So I'm not sure if I've answered your question because
you answered most of what I was wondering. I'm just thinking, like, I would love to get to use such a machine, of course, and it's definitely really useful. But in such a system where everything is costing and everything, for such a price like 50,000-70,000, I know that you're targeting mostly manufacturer at first, but I know I would never invest such a thing, because like for 50 or 70,000 euro, I can probably buy everything I would ever need in my life.
Right. Right.
I don't think it's aimed at individual people, though.
Sure.
Right. Okay. Yeah.
Well, I think a community of people who wanted to have the ability, one of the attractive basins for this is doomers and preppers, because world's going to end. We're going to have our own factory to get past the apocalypse and into the whatever. I don't like to cater to that mentality because I don't agree with it. But it is certainly a potential source of marketing.
Right.
But I think a community that looks towards, I don't know, you guys are solar punk movement, where it's sort of an anti-dystopian future that's not structured. But the solar punkers are pretty interested in cube spawn. But of course, they want to talk about it. They're living in a science fiction world. They don't really care. It's just cool.
Yeah.
Right.
Yeah. And but just cool doesn't buy me end mills, so so I have my finger in a lot of those kinds of small communities of people, but it's really for promotion, because I just want to get this done. I mean, that's really my focus. My focus is to get this done, move on to the next. The 3 steps from now is when the really cool stuff starts to happen. This is just mopping the floor. This is hard and boring. The exciting stuff happens after we get through these stages.
Okay, so at which stage can I say build an irrigation pump?
I'm sorry, you'll have to do it again.
I'm saying, at which stage can I build like a very basic irrigation pump?
Oh, you from the plans you can build any one of the machines.
Okay.
So you could have they kind of lose their value in isolation from each other, because the value is that they're working together and make this stuff possible. But if you if you built the 3D printer, I use the Ultimaker printer. It's a commercially available printer. I use their design because they're an open source company. So my printer is a modified Ultimaker. The milling machine's a unique creation because I couldn't find anybody that had a mill that would remotely fit inside of the envelope. So I designed that one. The lathe is going to be very similar. I have to design the lathe. And I have a partial design for it now. But those designs will be out as soon as they are operational. I have 99% of the mill done, but because everything I have is salvage, I have not yet found a set of motors and controllers that work well together. And I may end up buying some controllers because it's been a roadblock for too long.
Right.
But, buying stuff, that takes money, and there isn't a lot of that, so... And,
how can people support you?
Patreon. I put the Patreon link in the Jitsi chat. That's kind of the crowdsource. Crowdsourcing seems like a good idea to me. And once I get the mill done, I'm actually thinking of running a either Kickstarter or GoFundMe or something along those lines to try and say it would really be a bid to put that machine in production.
Right.
And the desktop version will be a little bit different than the manufacturing version, only because I don't need the outer casing and some of the other stuff that is needed. When it's a module and plugs into a machine, there's a lot of extra stuff that has to go around it. All that stuff wouldn't have to be on the mill if it were sold standalone.
Right.
It's a lot of
Okay. How plug and play is the system? Like how to get like 2 cubes to work together, kind of thing. Like how much?
Well, once a little more software work is done, it should not matter. Any 2 cubes should work together pretty much out of the box, because it's based on an emergent control model that's not really used in machinery yet. The machines just have a queue manager that assigns them work, and then they work on the work, and once they get to a point to where it's done, they tell their status to the queue manager, and then the queue manager goes to the next step and tells whichever machine is responsible what to do. So they really are they're black boxes to the other machines.
Right.
So it's an architecture that is basically doesn't require any control coordination between machines. It just requires control coordination between the queue manager and the machines. So it doesn't matter what the machine does. The queue manager can simply assign work to it based on specifications.
Excellent.
You know that this project, it was popping, like it was popular at one point. It was phone blocks. It was a bit of this idea of creating a phone, giving it different kinds of functionalities based on blocks. So you put one block, it's a camera. One block does this, like your fingerprint, and so forth. It didn't kind of take off. Are you familiar with that?
Yeah, I do. I remember actually Google got involved and then it died. So
Yeah, I think it was called Project Tara.
Well, in a sense, that's the modularity aspect of what you're trying to do.
well, I was really excited about it because I thought that would be a great preliminary product. Would be to make blocks for the phone blocks.
Yeah, right.
I mean, it fits into your idea really well. I mean, if your first module prints out the base case for the modular phone, the thing that everything else plugs into, that's already progress.
Right.
And what I wanted to say is that some people had a bunch of arguments from a maybe technical perspective. They will say, okay, but you update stuff, but what about the motherboard or the thing that you are sticking things into?
Right.
What about that? Because if you update that, then maybe you have incompatibility between modules. So what do you think about that in terms of your project?
Well, I think that the specification for these on the prototype, it's just a 50-pin plug on the back of the module. So a mechanical module, whatever it does, sort turnips, be a milling machine, be a 3D printer, whatever you are, it has 50 lines of communication to an electronics module. The electronics module is in the top half of the machine, or in the top 20% of the machine. The electronics module does not care what the module is because there's a template that gets loaded from the module ID that says, oh, this is a mill, I need to load this template. And when it loads that template, that reconfigures the G-code interpretation and the output pins so that it can operate that module. And every module has, this gets weird and technical, but the idea is that each module basically will have an SHA-1 hash so it's very much like GitHub. Instead of part numbers, everything has a hash, and that way, what parts descended from what parts too. If you make a modification, it gets a new hash, but it has linkage to the base part that you created it from. So the designs all stay together and they stay in families, and the ontology is managed by the GitHub type structure instead of having to do it in an explicit way. But all of that stuff means that basically when you load a module into the machines all know, or the controller knows what it is by reference looking it up in the ontology that's created by hashes. So on that basis, it doesn't matter what the machines are. And the config. So, to answer your question, do I feel that there will be a potential for enormous complications from incompatibilities by modules being different? The answer is not really. And that's sort of what that standards body is for, is that there's an upgrade to the backplane, and we change to a different kind of backplane. Then there's a before the backplane and after the backplane type of module. Then coming up with a way to migrate modules to the new standard, that would be what a central body like that would do, is it would organize the process in a way so that it wouldn't disrupt people's ability to make use of the system. You could do it progressively or in a phased fashion or whatever.
Yeah, and this is where recycling would be very, very critical. You could trade in your old body for the new one. A portion of the resources you could recover from recycling.
Right, or even better, you could feed the old body to the new ones, and basically allow the system the AR/VR interface and using AI for troubleshooting. Well, the idea would be to build up a library, because the idea is automation. These machines should be as automated as is humanly possible, or better yet, as automated as is AI possible, because. The idea is to turn most of the machine's daily performance and activity stuff over to the machines themselves.
Right.
And it's not like they're going to run away. The idea of, the Terminator, people brought that up when I first put the idea out. Oh, you're building the Terminator. And it's like, no, I'm not. The Terminator is about 100,000 times as smart as anything we've built to date. So it's only about, it's at least 8 weeks away.
8 feet away, actually.
Exactly.
Another thing that I've seen with this kind of debate between this modular phone and the normal phone, normal build, is that maybe modularity is at the expense of functionality and efficiency, because they say maybe if you build the entire package of a phone, we can make it smaller, we can make it faster, we can make it more energy efficient, rather than making a modular one that will be better in terms of modularity and you can do more stuff with it, but in terms of efficiency and in terms of how functional it is, that's a better way. So in terms of like manufacturing, how do you think that applies in your case? Making a factory that is specifically builds this kind of product maybe could be more efficient and more functional than building these modular ones that also have this kind of function.
You're talking economy of scale, basically, where if you have dedicated resources, I think economy of scale got us into this mess. Because if you have, let's take 17th century England, where you put in a steam engine so that you can make more pottery faster, but you couldn't make enough. There wasn't a good enough international shipping network for you to make all the pottery for everybody in Western Europe. You could only make pottery for a limited market. And the problem is that as systems have advanced, transportation has gotten cheaper and faster and better, then we tend to build things that end up exceeding reasonable scales. Now you've got most manufacturing occurring in China because transportation is too cheap, too good, and therefore overutilized, and that makes you commit to building systems that are way too big. By concentrating,
just to keep the wheels of industry turning. It's basically that.
Sorry, that was totally gibberish.
I'm saying you're making things for the sake of making them. Just because it's easier and faster and cheaper to do it.
But maybe that wasn't my question. Maybe that wasn't my question or what I wanted to say. I wanted to say more like a specialized factory that produces, say, some medicine or some products, some electronics. Maybe because it's built specifically to build those products, is more efficient in terms of energy consumption or the materials that it uses, and it works better because it's built for that, rather than a modular one that you build it for many kinds of purposes. That's what I'm saying.
And that's back to economy of scale. So this is the second half of that answer. So you tend to concentrate all your resources in one place because of this specialization makes you very efficient at producing something, and that leads to doing stupid things like putting everything in China. So the second part of the answer is that when you if you make things extremely efficient by centralizing them, that we get back to that thresholding problem where the efficiency with which you can produce things should be at a scale that only serves the market that is on the side of the threshold. Because what happens is you end up, like I said, if you put everything in China and you start shipping everything, you have this feedback loop where you now have a structural dependence because the factory is so large and efficient at producing 100 million units. You need a global-sized market, which means you need global shipping to accommodate the factory, and you have overproduction. You make 10 million units, there's only a market for 7. What do you do with the other 3 million units? Well, they end up as waste. So building super efficient processes leads you towards centralization. Unless the factory is scaled to the market that it serves, meaning a factory that serves southern Germany, that's a reasonable proposition. But a factory that serves the entire globe, that's probably not a reasonable proposition.
Right.
But I think in this society, it's not, because these huge factories, their purpose is to make a profit. So I feel like that's where, the problem usually comes into. And when it is at these huge, large scales, then you're giving a lot of power to one company or whoever's in charge of this huge scale manufacturing. So
is the
Right.
technology the fault, or is the motivation behind whatever people want to do with this technology? Regardless if it's modular or if it's centralized and not modular.
Right. Well, okay. So if it's the modularity, probably induces some overhead. I think that's what you're getting at is
Right.
by making it a flexible, open system, there is more overhead in it, and it probably doesn't produce any particular unit as efficiently. But if you're producing for an audience of 10,000, again, what does it matter in the time efficiency, and as long as your materials efficiency is good and you recycle, then does that overcome the inefficiency of not manufacturing it somewhere else? And if you look at shipping recycled materials to China, manufacturing goods, and then shipping them back to Europe so they can be sold in Africa, the travel burden that's on top of you make the unit very efficiently, but your overall system efficiency is bad.
Right.
yeah.
Right. So what's the metric for measuring this efficiency?
I'm sorry, you're
How can
breaking
you
up
measure
again.
this efficiency?
What is the metric for measuring this efficiency?
Oh, I would say, ergs per kilogram. How much energy went into making the unit, and how much
Embodied
energy?
energy basically.
Well, and how much energy did it take between the time it was conceived and the time it was in the consumer's hand? If you have a large proportion of that is shipping, or if a large proportion of it is, I think a local, slightly inefficient system makes more sense than a extremely efficient but very distant system. Now, I can't actually back that up mathematically, so I might get my toes toasted over the coals for it at some point.
Yeah, but theoretically it could be calculated, right?
Oh yeah. You could figure out what the energy impact would be, whether it would be a lot better. But I think that the secondary effects are actually more important than that primary consideration. You look at the energy profile of it, that's important, and you should know what that is. But then if you look at the autonomy of a local community that can make its own stuff versus one that's dependent on 8,000 miles of travel between China and their local port,
Right.
I think that's a factor that has to be considered as well. The coronavirus is illustrating this very well right now. We have an extremely fragile supply chain. A lot of stuff there's going to be a big economic dip because people can't get goods because the factory in China is closed down that makes that component, whatever it is.
Right.
Local manufacturing is resilient.
Is
Right.
it a problem with raw materials? You may say that you may find them locally, but making manufacturing more locally, doesn't it mean that you have to import or ship raw materials to different kinds of these local manufacturing plants?
Well, but everything that's made or purchased locally is already there, and its materials are already in the local ecosystem of goods. So the importing of materials will continue because there are some things that you just can't get locally in certain parts of the world. But I would say that would fall to a very small percentage of its current level. And then the rest of the goods, plastics, metals, minerals, all of that stuff is already there. It's either there in the waste stream or it's there in the goods themselves. How many tons of garbage do you suppose there are produced in Paris every day? And how much of that stuff could be refined back into products that were already there to begin with versus shipping it all in from China?
Right.
Or
So
wherever.
recycling is a big part of this idea. Recycling is a big part of locally manufacturing.
Mm-hmm.
Yeah.
That makes sense.
I like it.
Is there also like a big educational aspect? Like, are you wanting to spread a message through this project? And if so, like how would you explain this message in a nutshell?
the message is really about independence. You might notice on the website it says automation for the people. And I think that I am of the opinion that this particular idea sort of is difficult to condense into a short statement, which is why I have so much trouble with the finance guys.
Yeah.
They don't want a 2.5-hour conversation about it.
Yeah, right.
They want you to get out of their office.
They want you to explain how they're going to make money from this.
Please, in the next 5 minutes.
There's an entire show on this. It's called Shark Tank. Horrible.
Oh, yeah, right.
I hate that shit. I hate you, Shark Tank.
Shit.
Is it an educational, like also an educational value that you want to project to this project, like push to this project? And what is that? I think that was the question.
You're going to have to redo that because you're breaking up really bad now.
Yeah? Okay, I was trying to just rephrase Sasha's question, like, what would you say more about that? It's an educational aspect, and what is that more generally?
There's certainly opportunity for technology training, but I think there's also opportunity for community building education, because if you start producing your own food systems and you start creating a lot of other resources locally, that even non-technological ones, I think that every community needs to have a degree of competence to perpetuate its own survival. And that means raising your food, recycling your materials, manufacturing goods. All of those things are essential to maintain this kind of lifestyle that we have. And I don't think we have to give up the lifestyle. You know, a lot of people think because of global warming or that we have to change the way we live. And I think if we change the way we emit, we can live any way we want. If we quit emitting CO2 in such enormous quantities, which is mostly driven by transportation and improper management of biological waste and so forth, if we quit doing that, then we can build a clean society that has all the benefits of a technological society with very few of the negative impacts. Most of the negative impacts we have are from mismanagement.
Because in the end, it's always a movement of infrastructure and education, because technology alone, I don't think is going to change the world. Solar panels may look like a technology that coming from some alien species out there harnessing the sun energy directly. Even though we have that technology, it's not enough to change to reverse climate change. We need people to be educated about the problem and do something about it. So I always was of this opinion that technology and education, like infrastructure and education, work hand in hand. You can't just say, okay, nuclear energy is going to solve all the problems, or even modular manufacturing. I will not say it's enough. You need also to educate people about what problems there are, and then what solutions and why do you do these kinds of things. To help others, to create an environment where good behaviors can arise from. So would you agree with that?
I would agree to the degree that people are rational, but I don't know that they are. In the United States, we still have 80% of people believing that they're going to go to heaven. And the most of the ones that I've met, there's no chance. By their own criteria, they disqualify themselves. So you're implying that there's a potentially rational component to this, whereas I think that through technology you can structurally impart the results. So if you build a technology that does not emit, you guarantee that the people who use it don't emit. So you've actually solved the real problem. You haven't fixed them. You probably can't. But you're also not bombarding them with ideology. to try and change the way they behave because it won't work. You've gone directly to the problem and solved it. So I think this is a way of solving a lot of those problems, not all of them, but it's solving a lot of problems in a very direct way because the people who define the technology, the technologists, are responsible for how it acts. So if it emits giant pools of black crud every time it operates, that's exactly what everyone will use it for.
Right.
But if it doesn't do that, then you've solved that problem, or at least part of it.
Yeah, first of all, there is no such thing as like rational beings or irrational beings. People just arise from this environment. Charlatans are charlatans not because they're born like that. The environment makes them as they are. So I'm not, in any sense, like I'm marching against this kind of train of thought that people are this way or that way. It's just the environment that makes them. Second, I would say that even with the green technology, it can be abused. It can be abused by companies that can pollute in different kinds of ways. They may produce green energy, but they may be producing other kinds of waste. And even if we change climate change, if we fix climate change, we have a billion other problems left. That's why we always focus on this incentive, that's this trade-based environment that makes people behave really, really badly. And I would say whatever technology you put there, if you also don't promote a different kind of thinking or educate people about this problem, then I think those technologies will be abused. Like even open source is abused. It's abused in today's society. It's abused by Google, who builds Android and then builds basically an ad platform on top of it. It's abused by WordPress plugins or whatever other pieces of software companies. I was talking to Roma, who helps with Trom-Jar and stuff like that, and he works in server administration for several years now, and he was talking to me about how his company uses these open source software programs, pieces of software, regardless of the license. They use them and make a profit on top of that. So they don't even respect the open source. Where the incentive is there, people are going to, I would say, pollute any kind of technology. So I would still argue that you need technology, infrastructure, and also education. Else, infrastructure alone or technology alone is going to be used by people who are incentivized to put profit on top of anything else. And I know a bunch of examples.
Right. Well, I would agree that education is a critical element of, and of course, the foundational. What drives me to work on this system are don't emit, don't ship if you don't have to, consume the least amount of energy, pull the energy from, the local environment, all of those things. So I think that ethos is baked into it, and I think that teaching people about it has my view baked into it. The participants of the system, not just me, obviously, but whoever participates in it's going to help to shape that. And if you learn how to use the system and its components, then you're going to learn those things, or you're going to have to learn something about those things.
Right. So that's education. You learn. It's like learning on the job.
Right. Well, if you use it, then these things will be part of the process of discovering how it works. Because why did we do it this way? Well, we did it this way because emitting a lot of crap into the atmosphere while you do this process is not optimal or beneficial. Now, if you're just a consumer, just using the system, probably none of that comes through. You won't know why, and you won't care. You just want to get your thing, whatever it is. Yeah. So what educational message was the original question? And I think that's the answer, is that all the materials that surround the system to get people to be able to use it will probably sort of convey an ideology about not destroying the world while you get the things you need.
Yeah, and I like the decentralization aspect, to kind of give some power to communities rather than to big companies to manufacture. whatever.
It sort of avoids that centralization of ownership and control that is what drives the financial system. I don't have to buy your stuff. I can make it myself. Well, that pretty well defeats the, that defeats the General Electric selling me the component when I can make it myself.
Right.
I don't have to pay GE, and GE no longer has any real leverage. They do have all the intellectual property, but I don't think that's going to hold up for very long if there are hundreds of thousands of systems around the world making things. I think the IP is going to be indefensible.
Yep. I agree.
Of course, it's going to be. This is a huge battle, and we don't know how it's going to turn out to be, because some people may argue that, well, today people can have their own operating systems and they can make their own applications, and then regardless of that, only like 3% of people of desktop computers use Linux. Most people buy software like crazy because big companies have this huge monopoly that just push spoon-feeding people with their own alternatives, like their own centralized and paid for products. So having just the technology, I think it's amazing, but it's a huge battle to make it mainstream and to make people adopt that. It's a massive battle. I'll say.
Right.
Yeah.
Well, I hate to do it, but I'm coming to the end of my window here.
Yeah, we are too.
Yeah. It's been a while.
But
I'd like to chat with all of you again, in group or individually or however you like, because it seems like I just sort of realized what you were about 2 weeks ago. And the thing is, I posted a link to one of your subsites on my feed, and everybody said, "Oh yeah, that's Trom." I was like, "Oh, okay." Clearly, I've been in my closet too much lately.
Well, it was a very interesting discussion, and I'm definitely going to ask you if you want to participate in future Trom-Cast, because we can expand on this a lot more, I would say, and maybe I'll also contact other people from this open source hardware and manufacturing to come to Trom-Cast, and maybe we can have more. You see, we don't have.
You're gonna have to send me an email because you're breaking up so bad I can't tell what you're saying.
Okay, but you guys hear me, right? I think.
Yeah. It's just the internet. He's just saying he wants to get like a bunch of like potentially like open source enthusiasts, engineers, kind of guys in this field, kind of in this kind of setting, and have you guys kind of.
To maybe ask better questions.
Right. That you could elaborate on each other's ideas or whatever projects and things like this.
Right. Okay. I think that'd be great.
Hell yeah. All right.
It was great, James. It was really great.
Excellent. Yes. Thank you so much.
Thank you very much.
Yeah, thank you.
I appreciate talking to all of you.
Yeah, and to learn more.
Don't be strangers.
Yeah, right.
We are not strangers anymore.
That's true.
Okay, so you can go to cubespawn.com to learn more about the project and see if you can get involved. And yeah, it was a great Trom-Cast. I've learned a lot.
Me too.
And if you want to support the project, it's patreon.com/cubespawn.
Oh yeah. Okay.
Okay, guys, it was a very interesting Trom-Cast and a long one.
251.
251, and I'm almost peeing myself. I'll pee here if you don't mind. Just very soon, actually.
Yeah, right.
Do we finish the
You have to
live?
tell us about it.
No, but people know that I'm going to pee.
Yeah.
Right. They need. This is the updates.
It's a human need, okay? Mind. Yeah, and if people know about these kinds of other projects that are very interesting, like this one is supposed to be very interesting, tell us about them and we can make a Trom-Cast about that. And this following Trom-Cast, we're planning to make some about the self-sustainable communities. We want to project our criticism about that, but also maybe learn if there is something new to learn, and maybe we'll invite some people who are from such communities and so forth. And like I said a few Trom-Casts ago, we may also talk about the Venus project, because I think it's an interesting topic to discuss about. So yeah, we have a lot to discuss about in these Trom-Casts.
Yes.
Yes, my friends.
Okay.
Okay, let's just go and pee now.
Yeah, right. You have fun with that. All right. See you guys.
Okay.
See ya.
Ciao.